Hello, my name is Robert Harms. I'm the president of Lights in the Attic Project Group, or LIDA for short, and we have a number of business units. One of those key business units is a company called iSeent, and iSeent focuses on the bridging um, the academics, the science, the technology, the bench science that is just ahead of the the work that's being done or going to be done with respect primarily to artificial intelligence and whatever that means. Today, what I'd like to do is deconstruct to demystify the notion, the term AI, and to translate it, to break it down into to four different definitions, so that we can talk about what those are and where there is really application, where we are working and where we can be working and should be working across, particularly with a focus for capital projects. And the larger the project, the more fun it is, and right across North America and the world. So I've got a number of slides in here that I'm going to talk through and ultimately leave with you, just to help everybody understand this, or remember, hopefully, the term, the name of the company, iSeent. It's just a contraction of two names, and the one word is prescient, and so we've taken the scient off of that and make it iSeent, in that it's I see, I understand, and I'm looking forward. This specifically, what we're going to in what we call interim AI is the recognition that artificial intelligence is a very large and grandiose and even ambitious and unagreeable term, even with folks like Ray Kurzweil and the folks who over the last 20 years, 30 years, have really worked on the architecture of the concept. And even this group, very esteemed group, cannot agree on what AI is and whether it's going to take 5 years, 50 years, or 100 years, or even more to reach full AI, which is called AGI. It's artificial general intelligence. So what we do is we deconstruct that and say, the AI that is being the term that's being used by marketers and people around the world to kind of inject some mysticism and some black box into it, to say something really cool is happening behind here, and we're not going to tell you what it is. But so what we do is we break it down and say, hey, what we're looking at is a trajectory towards more complicated mathematics systems, tools, and the technology, the applied technology that work toward um, um, automation and autonomy to some degree, that are all still within the purview of and in the control of people. So we're not going to pretend that there is an AI that it's out there and it's spooky. And with the focus today, although this comes from a broader perspective, the focus today here is on capital projects and opex projects, and it really does have a lot of implications. But for the larger company, for engineering firms, for constructors, OEMs, etc. But it really is this focus is on projects. So breaking this down, starting at the very, very beginning, what we call AI zero, and there is nothing artificial about this. A is for anthropic. It's the people and what we know, what we do, and how we think and how we apply that. Just for a simple illustration here, when we talk about AI zero, if you remove the hand from this image, you're left with another image, and automatically we can see, depending on the definition of your screen, that there's a figure behind there. And because the hand is there, we automatically see that as we know that's a head and a body, presumably a man just by the form of it. But even at that point, we can be wrong. But a computer and software won't be able to, if you take the hand away, it won't be able to know what's back there. It could be a shadow of a bottle with a bottle cap or a water bottle, etc. And I think we need to recognize, first of all, that meaning is fundamentally human. There is no meaning in artificial intelligence. AI1, A is for augmented. This is when we're collaborating with somebody using a tool such as books in a library, or any kind of collaborative tool, communication tool, where the information and intelligence that we use and get is not completely our own as an individual. AI2, this is where really work started in business in the early 80s with software, with the development of, for example, Microsoft Suite and the other things that were around at that time, and designs, computer-aided design software. So this is where it became automated as downloadable, software that were executable files on our systems, which a lot of us still have, and now into the cloud, where the tools are available in a much broader base and easier, and creating mobility around the world. But that's automated. So automated takes instructions. It's a hardwired, so to speak, a set of instructions that enable us to do things faster and more productively, we hope. AI3 is where it gets very, very interesting. And this is where we are starting. We are not in an artificial intelligence environment, and we're not going to be in one for some time. Artificial intelligence here is when you develop a system and it learns from the data patterns that you don't plug in. So it learns patterns. Everything comes down to patterns because it doesn't have any conceptual capability. It has only patterns of data, and it's how those get represented going in and coming out, and the propagation systems back and forth that understand, that find patterns that can look chaotic to us, but they're deeper. AI4 is A is for autonomous, and this is where Hollywood likes to spend its time. So we're not even considering that at this point. So again, if we look at where we are, AI0, AI1, collaborative, and software, programming, coding, automation, and then artificial intelligence, and then in the far distant future. So we're here, and we're still playing around with here. I mean, in industry, looking at the platforms, digitization. This is all in here. Digitization is not in here. Digitization is here. This is where we also are, of course, and we're just starting on this one. So what we break when we look at introducing AI concepts or AI3 concepts, and for the rest of the conversation, I'll just use the term AI. Please recognize that I don't mean it the same way as that the television means that you can get a smart mat for your welcome mat for your door, and it's built in with AI. So I will use AI in the way I just defined it. So we use functional ladders. We consider this is nothing breakthrough. This is just the way we think about it, in that you take one step at a time, but you've got your eye on the future, moving further up. But it is not something where you can take AI and say it's going to solve all this. It won't. for today's presentation, what I like to talk about, I put it in the sense of like project management portals. And this, in this case, this is not a portal of, not necessarily a portal, which is a screen or a way to get in. This is a way to see something. It's a way to see things that information and insights that can help with our decision intelligence. It can help with making decisions, understanding risks, managing the business that we're in. This is not a technical, system in particular that you can go and buy. That's not what's intended here. This is a way to see the information that you need for project management. So we'll talk about some near horizon functional ladders. So some of the things we're gonna go through 10 items. And some of them are very near. Some of them are things that we as industry are doing, presently doing. Some are a little louder than others. But a lot of these things are things that I wrote in 2019. I wrote a paper about where we can go and where we should be going with this stuff as real practical applications to help us to leverage the potential and leverage these tools. So they vary from current to the next 2 to 3 years out. I do not get into today, will not get into quantum software or quantum computing, although we do certainly have our eye on that, and that is about a 3 to 5 year program that requires a separate discussion. So to keep it simple here, for at least for me to talk about it, these things are all exciting, so I tend to get too deep into that. So what we'll go through is each of these 10 items relatively quickly. There's a lot of words and meaning compressed in here, so I'll go through that, try to unpack it and communicate what I mean by those things, and recognizing that for some folks it's not going to have an application, and other folks it could be very, very exciting for your business. So in the EPC and project environment, one of the first things that we can do with a better information engineering is rapid remodel of capex and opex consequences of alternative standards and plant redundancies and layouts. The tools that we have, portend to do this, but it is what we don't have is the patternization, the deep systems and the deep learning systems that can turn this into a quick models. Now, it's not all just about brute horsepower. It is about a different way to find those patterns and those consequences without having to go through an infinity of linear equations and intervention with engineering. It's complex, and that's why it is we haven't been doing it yet. Number 2, fluid design model integration and iterative study with OEMs, original equipment manufacturers, and vendors for equipment and commodities. Now, what this means is moving away from the traditions, the traditional model where your engineers, the operations engineers, as well as the project engineers, begin working with different OEMs. Some of them are preferred equipment suppliers that the owner has, and others are going to be new. But the process of integrating the models and the design and working with more holistically, these are opportunities where, and more dynamically, these are opportunities where AI and some of those pattern recognitions and making that fluid, where it is doing a lot of the calculation, and we're increasing the OEM scope and responsibility in the overall plant design, and where even from right down to valves, to pumps, to pressure vessels. Well, the people who know those best are the OEMs. And we as an industry tend to not really dismiss, but we don't really capture the full value of the OEMs, whether they're a large company like GE or whether they're a small pump fabricator in your state or in your province. And that's where the people, that's where the engineering and the knowledge, the intelligence, the expertise, and the data is for the project design. And so by getting a more fluid design model integration with that, we can not only be smarter about things, but we can be faster and we can have greater certainty, and the operating teams for owners can be far more engaged than we have been previously. Number 3, to patternize and optimize engineering and full cycle supply chain workflows. This is where a sister company for Isient, partially, I shouldn't say sister company, but another company we're associated with, EPC Lens, is right now, has been working on and has developed tools for this. But it is, we're still in the front end of the notion of patternizing and optimizing the work cycle, the workflows in EPC between an owner, the engineering firm, the different consulting firms that support a central engineering firm, the OEMs, the contractors, the fabricators, the manufacturers, the module yards, right up all the way down to all those thousands of points of input with respect to materials and support for a project. Given any project at any time, a large project can have 5 to 10,000 individual pairs of hands working on it around the world. So a lot of that, or the key parts of that, can be optimized, and we're still working in a stone age. And I don't mean to be derogatory. It's obviously it's an exaggeration, but it's like and people get offended by it. I don't mean to offend anybody. This is an opportunity for us to optimize workflows, and part of the problem with that is that project people are always doing projects, and it's really difficult to rewire a company, an engineering firm, an owner who are capital intensive. This is part of the difficulty with doing this. So so EPC Lens are working on that, and it's the findings are quite interesting. Number 4, a live dynamic model of resources with business case analysis with environment specific fast simulations, meaning that it is, instead of looking at, when we get into a project, beginning of the project right through to further on, when you want to take a look at making decisions around the resources that are available, the changing conditions, particularly if your project is going on for more than a few months. If it's going on, as long as 2, 3, even longer than many years, the resources, the environment that we work in is completely different than the one we started with and the one we based all of our assumptions and on, and the strategy. So having something that works with the changes in the resource and environment data is with a fast simulation, that creates the opportunity to make much smarter decisions, and increase the confidence of predictability and success for the owner. Number 5, test and prove out alternative organizational models for integrated owner, project management organization, engineering, construction, and commissioning. Now, this doesn't mean that your model is wrong, or however you're doing this is wrong, but it's to test and prove out in a virtual environment, in a calculated environment, based on the patterns that we find with workflows and how things get worked, including liabilities and responsibilities, and how that can best be done in the entire organization that's going to deliver a capital project. That can be a small company that does projects irregularly, or a large company that wants to look at a new model for how it's going to deliver projects. Number 6, real-time market analysis into project controls and supply chain management. Now, this is something I've been working on for some time. In my background of 25 years in building projects, this is a very, very painful start to trying to be right and almost always being wrong about decisions and understanding what the market is doing. And there are a number of most companies have things like category management and different processes for to try and to calibrate, to measure, and get information that they think that is going to give them an advantage and help with decision making. And to some degree, it's true. It's extremely expensive. It's slow, and it really doesn't. There are a lot of things that it can do better with a slightly different approach. And so we've done this. We're working with this now and rolling it out with EPC Lens. But the power of this is quite remarkable, and it does change some things with how a project can get done, which isn't always making everybody happy. But it's a very this is another strong potential for using engineered algorithms and a different work process to improve projects and the opex side as well. Number 7, integrated risk modeling and contingency mitigation management systems, dynamic behavioral patterns and metrics. A lot of words. A lot of those words have a lot of baggage for us, and looking at risk modeling, contingency mitigation, management systems. It's going to make people's heads hurt, and mine included. But there is a real potential here to help, and we're not working on this yet, and we don't know of anybody who's doing this, even of all the major technology companies. This is something where the certainty and predictability of projects is largely contingent on this. When you look at post-project post-mortems of projects that have gone wrong, and there's a lot of them, there's a common, I guess, a common response by project teams and owners to say, well, it's poor planning. So much stuff is poor planning. And I think we've got the question wrong to a large degree. Now, whether planning was at fault or not, that's a whole big complex question, and we don't have to actually ask. The question is, how much planning do you need? This is what we need to focus on here, and what we can focus on now with the technology and the mathematics and engineering these algorithms, is to actually be much more aware and plan for the things that are changing, and the things that can change, and the things that you may want to change. To be able to look at all those dynamic elements in a more real-time basis, and as the future goes on here, that'll get the time required to do that is shorter and shorter. But at least to have a dynamic system between what's happening, and that is calculating, working with your business objectives and your risk model, you have a power to take decisions before something goes awry, before something goes sideways or pear-shaped. So that having that decision information is critical for bringing project costs way down, and getting rid of some unnecessary contingency, and being able to manage that much better with greater predictability, and to be able to go to our board of directors or our senior executive and say, we do believe we know what's coming. We do believe we're ready for it, and we have the tools in order to manage it. Number 8, dynamic and live resource benchmarking, multiple metrics. And this is having an ability to calibrate with a greater confidence and accuracy, using a number of different key metrics and KPIs, not only benchmarking, there was productivity and costs. There are a number of things that we can do, and I know there are a lot of arguments, and I face those arguments, in the business. And how do we approach things like, well, benchmarking requires a universal definition that is simply impossible to achieve, and I get it. It is not easy, and it's generally left at a very high level, which often doesn't give us a whole lot of information, actionable intelligence, in order to make changes or understand where we are. So this is something that I hope that we can move into, and certainly industry does need to do this. And the more that everybody gets involved in that, the better it is for everybody. And the focus can be not on competition so much between businesses, but actually just bring your own absolute value down to your absolute value as high as possible. Number 9, live capex and opex projects market intelligence. And so again, this is something we're supporting EPC Lens with, and their tool called MarketScape. And that is just understanding what's going on, not on a high level. Well, it is on a high level. It's scalar. It is in a micro level, intermediate level, regional level, pardon me, national, state, provincial, and international level of what's going on with projects and the cost, the trends, the availability of resources, cost inputs, different kinds of elements on risk, and sentiment. The people who, market analysts tend to think that they've got everything in hand, and they put out a forecast, and then reality transpires, and in the end we're left with some rationalization and some excuses and some things that were unforeseen, that explain the differences between the original forecast and reality. And with and that's great, and there's some terrific intelligence tools and people that do that. But what this tool does in this process, and where it's working with the AI, the algorithm engineering, is getting data from the ground level, from the grassroots, on a continuous basis, and looking at that and looking at the patterns, so that the reports, whether it's just basic data or it's more comprehensive information, or it is true analysis, based on complex patterns that we normally otherwise wouldn't see, and correlations to data that just simply are too complex for market analysts to conduct. This is the stuff that we can have on a daily basis, and on portals and dashboards. So this is obviously something that has been silently in progress for several years, and is very exciting. And from that, a number of these other tools become possible. Again, to be looking at that ladder process, you get a few of them at that bottom level, and it creates enormous possibilities. And you can decide your own trajectory with depending on your own corporate objectives. Lastly, number 10, the iterative pattern recognition of the lessons learned programs and collaboration systems. Now, there's most of us feel the pain, or have felt the pain of not only trying to capture lessons and things that have happened, whether they're small or catastrophic. There's a whole, that learning management process is difficult as it is. But to get it right, and to not blow things up a second time, is, that's where the value is. And we're struggling with that, not only with the industries at large, but even within an individual company. Is just, how do we make sure there's that continuous education, the recycle or the feedback loop with lessons? And this is one place where, there's a terrific opportunity here for the technology and the mathematics and the algorithms that are already available. That toolkit can be used to do something much, much better here than anything that I've seen to date. And I'm assuming that there might be some silent work there behind the curtain, but it is this is a terrific opportunity for all organizations, including the engineering firms and construction firms. Other things. This is something that's a little bit more on a strategic level, and it goes back to a statement made by the CEO of IBM a number of years ago with their strategy on how they're going to design what the architecture of their solutions are moving forward. And they really avoid the term AI, particularly high level conferences. They do use it otherwise at a more consumer level, but what their approach is to go is what I mentioned in it was AI2 is it's really augmented intelligence. And the way they want to do this, or the way they are doing this, is looking at all the different functions as microservices, and then creating a platform that looks at all of those different things. And this is, you can kind of see this with API systems, etc. But it's a platform that integrates those things and that can make them work together holistically, which is very, very interesting, and it makes sense. But one of the things that we can do that for organizations, specifically, stepping away from the IBMs and the large ones, is it's the algorithm-based deep learning form of having a consultant coming in, looking at a work process, looking at a workflow, whether it's supply chain, project controls, how you're managing finances for a project, et cetera. And while you're continuing work, you have a team, task force, or consultant come in and look at that, and then they say, well, these are areas where you can improve. Well, and that's great. And there is, but it's our operations are increasingly complicated, increasingly large, and increasingly the pace of them is and pace of operation, the pace of changes is so quick, and that how do you learn something about what you can where you want to make changes, how do you get to understand the ROI, the nature of that change, how much it's going to disrupt or impact your organization, and what's going to be the return on this, is what's going to be the end game on that, and what's it going to look like. Well, this is something where parallel deep learning through these looking at these different modules of operation can really help quicken that, accelerate the pace of that, find things and actually evaluate them, including the consequences, with much greater accuracy than we can presently. The way, so those are the 10 items that they're not comprehensive, they're not exhaustive by any means. There are, it's a barrel full of fish out there, and so 10 items, and the notion of how we can move forward with some others. There are a lot of other opportunities, but generally, what the way we need to work this now, it is a vertical process. It's a vertical and a horizontal process. Whereas we typically, since the early '80s, we saw the need, industry adopted the model of having an information technology or an information systems stratum across the organizations to support software tools, the hardware, et cetera, even communications tools, et cetera. Well, the way I see this is going to happen is we're going to be adding another stratum here that is horizontal, and it's really algorithm engineering for business intelligence and decision-based intelligence-based decision making, and so it's different people, it's a different skill set. It's not the term data science as it's being used now, but it is really truly science and data engineering, algorithm engineering combined, overlapped with business management. it's not so much how the microwave works, it's what you put in it to cook. So we do this with, there's a top-down approach, really. It is starting with the corporate vision, the research, and then it goes into the theory, the things that are happening in our universities today, and how that turns into applied science and then into technology, using the latter concept to go one bit at a time, but having a long-term trajectory. And then looking at the adjacent elements, the factors, because as we become more integrated and the data becomes horizontal, excuse me, we have to be much better at looking beyond a single business unit, looking beyond a single discipline, and having being mindful, I guess, of the adjacent impacts and adjacent industries. Like there are things happening in medicine and manufacturing that have immediate direct application to the things that we're doing, and there's some really terrific ideas there. So, and then how that applies to the solution design, so we can finally do the solution design, engineer it, and actually get into tangible, real applications. So those are vertical concepts, and there's a lot to be done there. So you have to take all these different strata and look at it that way. This is no longer we no longer tell the IT group to go buy some software. So thank you for the time, for letting me talk about those things. I think that it's a very exciting time. It's a very anxious time for a lot of companies, and perhaps some of I think that the fundamental notion here is that it is, while it may seem daunting, there are things that we can do that have a terrific return, that won't send us sideways, whether it's a company or an industry. And we just need to recognize, break this thing down into, what can we actually do, and how can we do that? So today's discussion comes out of an education series that I'm working on to deliver. It's called Interim AI, based on a white paper, an ebook actually I wrote in late 2019, and it's available. Pardon me. But some other things here that you can see that we have been working on, particularly in Canada, is the Indigenous Lens here, which is applying a lot of this stuff to understanding the Aboriginal, Indigenous, First Nations, Native Americans, etc., how projects can integrate with these communities. And a couple of the other things that I've done there, one of the things I'm quite excited about, as well as what's coming up, is we're introducing a nonprofit called Capex Science. So I'm hoping that I get to talk to you about that as well in the future. Just a little bit about ICENT. We're working, basically it's the engine for EPC Lens. My group, the LEADA PG line tamer, which does the execution planning, and the Turtle, which is a new development with an Indigenous group in Canada called Turtle Island Workforce Solutions, and how they're creating a fabulous organization of trades across Canada with using our systems to create visibility and management systems.